In today's show, we discuss another of our popular Dynamite Conspiracy episodes, and we talk about where does the moon actually come from?
And now, the TNT Talk Show, daring to go where other podcasts fear to tread.
Hello, I'm Tony Fasula and I share the stage with my esteemed friend and colleague, Tayo Boya. Tayo, hello, my friend, once again. I hope you are keeping safe and well.
What the hell, Tony? What you gonna do, eh?
Oh, come on, be upbeat. You know, I want to bring my energy and pass it through to you and make you smile and make you be excited.
Okay. Why do Ecuadorians never have sex ed and driver's ed on the same day?
Hey?
Why do Ecuadorians
Yeah.
never have sex education and
Yeah.
driver's education on the same day?
Go on, enlighten me. I don't know whether I should ask, but go on.
They gotta give the donkey a break, man. Come on.
Oh.
Did you
That's
watch
terrible.
did you watch the Grand Tour with I think it was the Grand Tour. You know the Grand Tour
Yeah,
with
yeah.
those three blokes from Top
Used to
Gear.
be Top Gear, yeah.
So they were in Ecuador
Mhm.
and they were driving along and they were filming, and then the tall one, what's his name again? The
Jeremy
tall one.
Clarkson.
Clarkson says, "Hang on a second, did you see that?" And we were like, "What?" And everybody saw the camera stop, and then they sort of like pan over to like a field or something,
Yeah.
and there was a man standing behind a donkey, doing it to the donkey in broad daylight.
What?
Broad daylight, no shame, nothing, just
Really?
yeah. And it was sort of, I mean, everyone's standing there thinking, are we actually seeing this? This is a setup.
They filmed it as well.
Yeah, they filmed it.
Oh, I'm
Went out on
surprised.
air.
Dear me. So we don't have to do an adult show here because of that joke.
Possibly. Oh,
Oh dear,
wow,
I've still
wow.
got my COVID cough. It's still here
Goodness
after.
gracious me.
I know.
COVID, yeah, it's not easy to get rid of, is it?
No, 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 no. Anyway, let's move on with the
Swiftly.
show. Now, in today's show, it's quite an unusual one, actually. We discuss where does the moon come from? Now, I'm a bit flabbergasted by this subject. It wasn't me that picked it. I've got to give all that credit to Tayo. So, Tayo, please, please kick us off. What do you mean, where does the moon come from?
Well, just what it says on the box. Where does the moon come from? There have been a few theories rattling around. The Apollo moon missions were meant to settle the question once and for all. And we still really don't know. So this is not a conspiracy. Well, it's not a conspiracy.
It could be, couldn't it?
It's not a
where you're
conspiracy
going.
in the way you'd normally think of it.
Okay.
But since I am going to argue that ultimately it ties back to simulation theory and a simulated universe, I suppose you could say in a way it's conspiracy, but that's ultimately my position, and that's my belief is that that it's one of the tokens that was left to us by the simulators, so that eventually we'd be clever enough, wise enough, and knowledgeable enough to realize that this is I don't like to call simulation, we've argued about this before. I like to call it a virtual reality, and that it's up to us to deal with that as we want, because it's an amusement arcade. It's the ultimate amusement arcade. So
we're effectively in an Xbox game, and this is part of it.
Yeah.
But
And
then why go to all the trouble if this is what you're alluding to, that the moon is is not a natural thing that sort of came about like the other bodies in the sky. It was what, placed there?
Pretty much.
And
Pretty much.
where's the evidence for this? You're a facts and evidence sort of guy. So
Mm-hmm.
where's the evidence for this? I mean, I know there's some weirdness about the moon in terms of, you know, the distance it is from the Earth and the way it rotates. It's perfectly in sequence. So we only see one side. I get all that. And I know about the moon and the sun, because the distance that the sun is 400 times bigger than the moon, but because the moon is a certain distance, they look the same size in the sky. But that's just a coincidence. That doesn't mean that it's been put there. So what can you enlighten our audience as to why you don't think it's just a big lump of rock in the sky orbiting our planet?
That is a very big, very strong piece of evidence. And it's what we're going to look at here is the preponderance of evidence. There's no smoking gun here that that's the final proof. But when you ask enough questions, you start thinking that, look, this is a setup, man. Um, Besides, when you talk about, I love the Cavalier wing, which you said, it's 400 times smaller. It's 1/400th the size of the sun. It also happens to be 1/400th the distance to the sun. And you've brushed that off lightly as being a coincidence. But if you were just simulating random objects in the sky, the odds of coming up with that particular formation or any similar formation would be astronomical. There's no such other object in our planetary system. So it's a little nice that you just sort of
It
write
is,
it off.
but for what purpose? I mean, so
Oh,
what?
well.
So what?
So actually, according to those who claim to know better than myself, it's just because that we were able to study the corona of the sun whilst it was in a full eclipse. That's why you have all those cameras and things trained on it, by the way, that we were in part able to confirm Einstein's general theory of relativity. Did you know that?
I wasn't aware of that. And that was
Yes,
because of the eclipse.
that was because of the eclipse. It allowed us to see stars behind the moon, the sun, which would normally be hidden. But enough of the sunlight was covered that our cameras were then able to look sort of past the sun and look at the bend in the stars behind the sun and realize that the sun was bending light because of gravitational effect on light, and that helped confirm Einstein's special theory.
But could
that's amongst other things, by the way.
Okay, yeah. But in that single thing, though, that in its own, that could be just, like I said, it could be a coincidence. Yes?
Yes, that single thing just on its own could be. So let's have a look at this. First of all, where does everything, our planet, have you heard of not our planet, our planetary system? Have you heard of the nebula theory?
No, that I haven't.
Well, the nebula theory is one of the theories, competing theories, but I'll say it's the most popular theory of the appearance of planetary systems. It's argued that initially, the universe was just big clumps of cloud and dust. Well, yeah, dust and clouds like that, right?
Yeah.
Clouds of what? Of material.
Yeah.
And that in this swirling mass, clumps started aggregating together, and that caused, as they grew bigger, they started getting gravitational effects. They started pulling in material, and slowly but surely, what you started having the formation of stars. And around these stars, there were swirling masses, again, still, because it was all from the same source, obviously. There were these swirling masses of other clouds and other dust, and that these started clumping into what are called planetesimals, which are sort of asteroid-sized clumps of rock. And that these kept on bashing against one another and then growing bigger and bigger and bigger until they achieved their own gravitational effects, if you like, and became what we know as planets today. It is argued that the clouds flattened into a disk shape that All that's why when we look up into the sky, and we look at all these galaxies and whatnot, they're disc shaped. The argument being that it's like spinning a lump of dough. It's like spinning it into a pizza.
Yep.
You spin, 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 and then just kind of
it flattens, doesn't it?
It kind of flattens out. That's the idea. So if you look up Wikipedia, it will tell you that the clouds in the nebula theory, the clouds flatten due to centripetal force overcoming gravity.
Okay.
That's what they claim. I'm not quite sure how that's supposed to work. I've tried to imagine it, but well, there we go. Answers.com, on the other hand, argues that these clouds flattening out as a natural consequence of collisions between particles in the nebula, changing random motions into more orderly ones, which sounds like a total cop-out. I mean, you could turn, why not into a triangle or into a square or something?
Well, can I just jump in there? There are things that do go into order over a period of time. The game of life, have you heard of that?
No.
Yeah, it's a computer simulation. It's very, very simple. It has few basic rules, and when it works, when it's playing, you can see it play out on a computer screen, and at the moment it looks all random, and then after certain collisions, the patterns start to form, and based on those rules, those forms, and then they start to sync. They start to synchronize, and then it no longer moves. So the game of life, that's what it's called. It's a game that then synchronizes to a uniformed. So it started off random, and then it goes into orderly. So it seems to prove by the very simple equations that are put in place that randomness will eventually go to order based on external forces. And what you're saying about the dust, if it's moving and there's enough gravity competing against it, it can clump together like you described with the pizza. It brings it together. So it starts to form in an orderly circle where they're all brought in together. So there is some conformity and order when you get a lot of gravity together. So it's not ultimately dismissed. If it was just flat and not non-moving, yes, I get your case. But if it is moving, then movement in itself will generate some sort of order eventually.
I think there's all sorts of things wrong with your understanding of order. One system that we can say is naturally ordered are pebbles on a beach. Is pebbles on a beach. As water brings the pebbles forward, it sorts it out normally, and the smaller pebbles are carried further up the beach. The larger pebbles are not carried as far. So over time, you see an ordering emerging on the beach, with the smaller pebbles, further inland, and the larger pebbles more towards the shoreline, water, if you like, the water. Right. That's a natural ordering, and nobody's arguing that it doesn't exist. I'm arguing in this particular case that I don't see how randomicity selects for a disk, a flattened disk. It doesn't. How? What's the mechanics of that? Why would it flatten out? Why wouldn't it just become a ball? Which I think is the most logical shape for the smallest surface. The smallest surface with the most amounts of mass is a sphere, and that's why planets and other things are spheres. So why is it a flattened disk?
Because it hasn't got to that disk shape yet. Yeah, they're still significantly far enough apart, but still being affected by the
why flat? Gravity. Why flat? Why flat? Why would it be flat? What is making it flat? That's what I'm saying. I'm talking about this answers.com thing. And the other thing is this. If you got an infinite amount, well, even if it's not infinite amount, if you've got something in space and you've got gas, why is it coalescing instead of expanding? Because we know that gas expands. That's its natural instinct, is to expand and fill the space. So the physics of it is unknown to us. We don't see things. We don't see gas coalescing. We see gas escaping. Its natural order of gas is to escape, is to get away. And just saying gravity is like, yeah, well, which has to come first, though? The gravity has to be there first. Do you see what I'm saying?
Yeah.
If the gravity is there
In
first,
space, there is no, when the gas first developed, there is no gravity because things haven't formed. So it is
exactly.
doing exactly that.
So the Big Bang would suggest that everything is scattering, everything's moving away from each other. So when did it start forming into
When it slowed down, when it was enough for gravity to take hold, because gravity
what
isn't
gravity?
that...
We've just said there was no gravity.
Yeah, but there's going to be some bits that are going to be exploding closer together, and as they're slowing down, they're close together, and so they're
moving apart
together
all the time. So you are saying that somehow they're together long enough to somehow have the kind of gravity before they're big enough to have the gravity, even the microgravity. Basically, you're referring to, let's say, microgravity, because that's what it has to be initially. It has to be micro on a microscopic scale. So is that force of gravity, which already we're saying is quite a weak force in the grand scheme of things? How does that work?
Yeah, but in the Big Bang, the universe hadn't sufficiently cooled enough until 700 million years after the Big Bang, and nothing was forming. Even elements were not forming because everything was still too hot. So it was only after a considerable period when things started to cool down that elements started to form, and then there was we don't know how they attracted to one another, but it seems really bizarre.
The nebula theory starts off with, if you like, protostars, and it doesn't look into where do those protostars come from.
Okay. All right. I mean, we're getting in real deep stuff here, but what does this say about the moon? We're digressing.
No, we're not actually. No. Okay. I'm telling a story.
Oh, okay.
And then the third reason is Bartleby.com, BARTELBY.com. And Bartleby says that the flattening of disks occurs because of the gravitational influences of nearby stars. So you need nearby stars to act on disks, on nebulae, in order for them nebulae to flatten. The only thing I'm trying to say here is that modern science, you can see, has got different interpretations and different ideas of why disks flatten. So by no means is it a done deal.
Okay.
All right. Okay. So now looking at the planet Mercury. All right. We're going to come from Mercury. We're going to move towards Earth, and then we'll go to the moon.
Yeah. Okay.
Mercury is extremely dense. It is too small to have the density it has. So it must have about 75% iron core. This is when they sent up a probe, and then they measured the gravitational effects on the probe of Mercury, and they realized that, wow, the gravity is too big for such a small planet. And that 75% iron contradicts the nebula theory, because the nebula theory suggests that the smaller planetesimals, which are coalesced closest to the stars, can't have certain materials in them because the sun is too hot, the star is too hot, it burns off that material. Do you see?
Okay.
So iron, in 75% iron shouldn't be there in Mercury.
So what are you saying? Is it not there, or are you saying that the science...
It is there. It is there, but according to nebula theory, it shouldn't be there.
Right, okay.
So some clever clogs came up with what they call the high impact theory. And the high impact theory suggested that in those early days of the formation of the planets swirling around, there were clumps of various materials, and one of these was a huge lump of iron, like an asteroid. And it came and it hit the young planet Mercury, and the resulting mass is what we're looking at today. And Mercury as a planet with a very heavy iron core.
Okay.
that has the gravity. So it's that high impact theory
Okay.
making its first appearance. The second planet out. Yes, go on.
No. I mean, okay, you've explained that. Now go on. Go on to Venus. Yeah, second planet.
The second planet out is Venus. Venus, as you know, spins backwards on its axis.
That's right. The only one to do so.
The only one to do so. This defies the nebula theory because obviously everything was spinning in one direction. So
could have been hit and then
it could have been hit, you see, another high impact theory event, right?
Okay.
It could have been hit, although if it was hit, it's a little strange that Venus is only 2 degrees away from perfectly perpendicular on its axis. So that's asking, for quite a lot, that this huge asteroid came along, hit the planet, was able to stop and then reverse its axial spinning, and yet only disturbed the planet by 2 degrees from its perfect perpendicular. It's asking a lot. And also, it resulted in a planet. Venus has, I believe, the second most orderly orbit of all. I think Earth has the most orderly orbit, by which I mean it's very nearly a perfect circle, right behind Earth. Okay. But if it was hit by this cataclysmic asteroid, how come then the resulting order is so perfect? Nearly perpendicular axis and nearly perfect circular orbit around the sun.
What's your conclusion in all this? I mean, are you trying to point that science, it hasn't got a clue? Is this the purpose of this decimation of the theories? Is it that it doesn't make sense when you put it all together?
Remember when I said that being close to the sun in the nebular theory means that volatile materials are burnt off? Yes?
Yeah.
All right. So on Earth, one of the most volatile materials we have is water.
Okay. Why is it volatile?
Well, because at just 100 degrees of Fahrenheit, no, 100 degrees centigrade, blooming thing boils and turns into vapor.
Okay.
Right? Unlike, let's say, iron, for instance.
Yeah.
Well, what were the other day? We were talking about steel, weren't we? Although steel is a man-made object, isn't it? But iron, what is it? 1,800 degrees.
1,800 degrees before it can.
Before it. So you see, I mean, obviously, all the water will be gone before the iron starts going, right?
Mm-hmm.
So how did the scientists explain that Earth has got water?
These are not collisions from, they don't know really.
High impact theory comes to the rescue again. All this water carrying asteroids came out from nowhere and hit the Earth and dumped all this life-giving water here. And a happy coincidence, and it absolutely disappeared. And we've not seen the like since. But there we go. This is what happens when you wait long enough. Anyway, that's why we have water on planet Earth, right?
Okay. I'm still dubious about that theory
well,
myself, but okay, that's
the nebula theory. Now Mars.
Okay. Yeah. How come we're passing all the planets and not mentioning the moon, seeing as really the topic was about the moon?
Mars is the last one, and then we'll come back to the moon.
So we're doing the solid planets only, not the gaseous planets.
No, no. I mean, we could have, but I thought it was just going to be a bit too much.
Okay, Mars.
Mars has a very thin atmosphere. The planet cannot retain water.
Can't retain water. We don't know that yet.
No, it can't retain water. The boiling point of water is too low on Mars because of the thin surface. I can't tell you what it's. I tried to find the temperature, but it's ridiculously low. It's something like 40 degrees C or 50 degrees C, something like that.
Okay.
Yeah, the water will just evaporate. It won't stick around. So, however, the planet does seem to have a lot of water-related geological features. And it is postulated that once upon a time, Mars did have
water.
Yeah. And then we can ask, well, what happened to all the water on Mars? I think you're beginning to guess. There was this high impact event. There was
all
this
got-
asteroid that came from somewhere and hit Mars. Right?
and got rid of all the water.
And got rid of all the water, causing catastrophic dehydration. And what is really lovely about this is, if you think about it, on Earth, the high impact theory led to hydration of the planet, and on Mars, it led to dehydration.
Okay.
Now that I've set this all up for you, let's have a look at the moon, because I just wanted that to be in the back of your mind, that when the scientist jumps up and tells you, the moon is because of the high impact, you'd be like, that's why I laid the foundation.
Okay.
All right, so the moon.
Yeah.
Very important for us. Apart from it being 400 times smaller than the sun, which we've already spoken about, and the coincidence of it being 1/400th the distance of to the sun, so that we see these amazing solar eclipses.
Yeah.
It also causes tides.
Yes.
Which, of course, prevents the oceans from stagnating.
Yeah.
It's interesting that if the moon was much closer to the Earth, these tides would actually be tsunamis. They'd be tremendously high and extremely damaging to the coastlines. Probably would have ground down most of the land above the water by now if it had gone on for a considerable period of time.
Okay.
There are things called meridian, which is these discolorations that we see on the surface of the moon.
Yeah.
Now, these were caused by objects hitting the surface of the moon, breaking the crust, and allowing lava to flow. And then the lava would cool and give this kind of coloration.
Okay.
And those colorations are called meridian. Now, what is weird is that the near side of the moon, the side that we see all the time, has far more meridian than the far side of the moon.
Yeah.
And scientists were not expecting that. They were expecting it to be evenly distributed.
There is a discrepancy between the two. It's quite profound, actually.
There's a profound discrepancy between the two, which no one has been able to explain. Polar missions were supposed to come back with some kind of answers for that, but they didn't. At any rate, there are 3 theories in place for the appearance of the moon, for the existence of the moon, right?
Okay.
The fission theory, the nebula theory, which I've explained a little bit, and the capture theory. What's the fission? Yes. Okay. What's the fission theory?
Don't know.
The fission theory is that once upon a time, the Earth was spinning so quickly that it threw off a large mass of matter, which became the moon.
Okay.
So this huge chunk was drawn away from planet Earth,
right,
and then as it's receded from Earth, it started slowing down and slowing down, so now it entered into orbit around the moon. Okay, so the first problem is that I don't think anybody has managed to show convincing mathematics about this happening. They're still trying to work out the maths for it, because we will come back to this again very shortly. And the reason the Apollo mission sort of poo-pooed the fission theory is because the rocks that came back from the moon are markedly different from the rocks that we have here on this planet, on Earth.
So they're not shared. They're not from our past.
They're not from our past.
So it's something entirely new that's been the bodies of the moon. Okay.
Yes. Okay.
Okay.
And in any case,
yeah,
to have reached a velocity sufficient to throw off the moon, or what would become the moon, it's been calculated that the Earth would have had to spin once every 2.6 hours.
Okay, way too fast.
Which is motoring. But it's not so much that it's too fast, because it was too fast is why that chunk of it broke off. The trouble is, how did it then slow down? So we don't have any natural physics to show how it slowed down to this nice meandering 24-hour period that we have now.
Let's go back to impact theory.
Let's go back to
the It's the answer for everything. Why not? Come on.
Well, there's the moon's core. If we're looking at the nebula theory, the moon's core is proportionally smaller than the Earth's. But if it was the nebula theory and the two objects had formed from the same processes, why aren't their cores of approximately the same size? Why is one much smaller than the other? Also,
well, this
why
I
do
mean,
the rocks
from
differ?
what you're saying now, even by the moon rock, would suggest that they're not
Exactly.
They're
Then
not.
obviously,
So that theory of it coming from the Earth is pie in the sky. It's come elsewhere.
exactly. Well done. So we don't even see. So the nebula theory is sort of DOA, dead on arrival for that, for the appearance of the moon.
Yeah.
Then we come to the capture theory.
The capture theory. Go on.
The capture theory suggests that the moon was formed elsewhere.
Okay.
It was wandering around. It got a little bit too close to the Earth, and then the Earth's gravitational field captured it.
Mm-hmm.
Yeah, took it in, and it snared it into an Earth-locked orbit. Now, if you remember with the fission theory, right, we had this problem of how did the Earth slow down?
Yeah.
With the capture theory, we have the problem with how did the moon slow down? Because it was wandering along, and it must have been zipping along, and if it zipped along,
how do we know it zipped along? We don't know. That's open for debate.
It had to be zipping along, or it would have fallen towards the sun or something else. So it had to be motoring along at quite a rate for it
asteroid
not to...
speed.
Sorry?
An asteroid speed.
Yeah, so it's not meandering is what I'm trying to say. It's not hanging around. It's actually motoring. Yeah. But when it entered into the Earth's gravitational field and was captured, how then was its energy dissipated?
Could it have been just the fact that it was traveling faster, got caught up in the gravitational field, and so slingshot round because it was going straight when it wasn't, it was caught in, so it started to be brought in over, and maybe it was further out traveling faster, and over time it's now
over time, what does that mean?
I mean over the time a massive number of years, it's now slowing down and got into a nice cylindrical orbit and slow. So maybe the moon could have been traveling faster.
No, sorry. I'm telling more about this over time. I don't understand over time. So this thing was, let's say, I don't know, 100 million miles away, okay?
Mm-hmm.
And then it came towards Earth the very first time.
Okay.
And then we'll take it from there. I'm not following your theory. What happened next?
Well, no, you said it got caught in the gravitational pull of the Earth.
This is not me. This is the capture theory. It got caught, and it had to happen once. Because when you're talking about over time, that's what bothered me.
No. It got caught, and then it was spinning further away than the moon is now, and because the Earth,
like it kind of settled.
Yeah,
into its,
so it catches it in its loop in the Earth's gravitational field. So the moon may have actually been further away in the past and slowed because the Earth brought it slowly, steadily closer to it. And in fact, the moon, I don't know, it's got into a geostationary orbit. It's now comfortable. It's not being pulled to the Earth, but still got enough momentum to keep it where it is. Maybe, this is just a hypothesis, the moon is not getting closer or further away because it's got itself into a nice orbit that it's got this synchronicity and balance in.
Okay, so if you think about it, trying, let's say you're on a slow train, and you got your arm out and you want to snare something, right? On a station platform.
Your arm will come off.
Well, that's why I said this slow train.
Okay.
Because you would rip.
You wouldn't want to do that, but yeah. Okay.
Or it's a small child or something, and you can lift up. You do realize that there's a co-equal force on you.
Yes.
So if this moon that was coming along and you're saying that was captured like this, one of the problems you find is that yes, the Earth is acting on the moon, Well, by golly, the moon is
The
also
moon
acting
is
on
also acting on the Earth. Yeah,
is also
indeed.
acting on the Earth, and you'd expect to see some sort of issues from that. Now, I don't know the mathematics, but I do know that by and large, scientists poo-poo the capture theory. They don't think
Well,
it's
okay.
realistic.
You're saying scientists poo-poo it, but you've just said that we poo-poo the impact theory. What's it called?
Oh,
The
but what do scientists then say will actually happen?
don't know.
Okay, so scientists think that a Mars-sized asteroid.
A Mars. So back to impact theory.
Back to impact theory. They think that a Mars-sized asteroid came and struck Earth a glancing blow, you see, and shards of Earth and shards of this other object mixed together flew up into the heavens and coalesced into the moon. Because
that sounds even more ludicrous than impact theory.
Well, that is where we are now. It's the high impact theory is the creation of the moon, and it threw off one, and altogether it was. Remember what I was saying about the why 1/400th of the sun, the size of the sun. It threw off this mass that just happened to be 1/400th the size of the sun, and left it in the geostationary. Well, not geostationary.
I mean, I'm not too bothered about this 1/400th of the sun. That's
I am.
Because it's not a relevant number. If it was pi, or if it was some other weird,
it just had to be. It just had to be. It's x times smaller than the sun, and it is x times away from the sun. That's all. It doesn't matter what the number is. That's what makes it weird. Right. The coincidence is a bit much.
Okay. What other coincidence? Because because we're moving on. We're actually rabbiting on here. I don't want to get out of time.
Also, we know that for this high impact or any other theory for that matter, because of the reflectors left on the surface of the moon by the Apollo missions and the Russians, and they're bouncing light off it every so often, and they're measuring the distance of the moon from the Earth, we know that the moon is receding from the Earth at a rate of 1.5 inches per year.
Okay.
Meaning that if we bring it closer, if we roll back the clock and we do the mathematics, the recession would have been significantly faster in the past. So when we wind it, we have to wind it and increase the rate. And then we'll say that, in 1.4 billion years ago, it would have been in contact with the Earth. But tidal forces, gravitational forces, and other things should have ripped it apart to smithereens.
Okay.
And it didn't. So we don't know, again, maybe one reason why we think, well, what's the story with the capture theory? That's another thing. If they come that close to the Earth, other things could have happened. And then we have something called transient lunar phenomena, TLPs.
Okay.
Transient lunar phenomena are little flashes and streaks of light and things that we see on the moon's surface. They last minutes or hours. They're well documented, and absolutely no one thinks they're aliens before we start thinking about aliens. Okay, nobody thinks they're aliens.
Okay, so what are they then?
We think that they are impacts from impact from meteor showers or whatever it is, hitting the moon's surface, cracking the crust, and exposing lava. Because, did you know, the moon is still geologically active.
So we should be seeing volcanoes erupting if that's
it's not that active. It's just semi-active. It's got enough lava. It's got molten lava under the surface, which after 4.5 billion years shouldn't be there. It should have cooled off because it's not large enough as an object to have a molten core, and yet it does.
So what are you with this statement alone? Are you saying therefore the moon either isn't as old as we think?
That's right. That's it. That's one. Two.
That's one. And two, it's way younger and hasn't collided with the Earth or appeared. It's been placed there.
It's been placed there. That's my thesis. That's my thesis. That's my
Okay,
theory.
that's interesting. Interesting. Okay, we're the TNT talk show. We do conspiracy. We look at facts and evidence. Although there aren't any for this, it's just a conjecture. But it's an interesting theory. But if it's placed there, that would imply some intelligence to place it there.
Mm-hmm.
And why? Why is it placed there? What's your
So
theory on that?
So that we could study the universe.
We? Who's we?
Humans.
So it was put there for our benefit.
It's put there for our benefit to help us study the universe.
So have we been seeded here then? Or are we just
seeded.
part of this game?
We're part of the game. And I don't like the word seeded. And as I told you before, there's this growing science. It hasn't got a name yet, but we are trying, some people, not everybody, some people are trying to prove that we have a unique vantage point, that the Earth is actually not in a random place in a meaningless part of the universe. You know how people like to say it's just a small planet on a backward
well, I don't think they're that disingenuous. I think it's just trying to make people understand of the scale of where we are.
Yeah, well,
I don't think it adds value.
Yeah, and this, we're insignificant. It's in backward. When I say backward, a backwards, maybe backwards planet. It's not, anywhere interesting. It's just, but apparently not so. Apparently, if you were to move Earth a few million light years, we wouldn't see the quantum effect, redshift quantum effect. So we have to be where we are to get these things. And that does not suggest a random placement. That suggests that this is not a random placement.
Just for that one thing.
No, I'm saying that to observe that we are amazingly well placed to observe the universe. We are so amazingly well placed to observe the universe that we got to not think that it's a random event. We're too well placed. You can't be. It's hard to believe it's an accident.
Okay, this now. Where we're going with this would imply an intelligence that's placed us here.
Right.
Could be, is it aliens? You said at the beginning, it's not aliens on the moon. But
no, this is
could it be aliens?
The problem with the alien theory is that how did they get started?
Well, alien doesn't necessarily mean little green men who are equal to us. Alien could be a body of intelligence which is way beyond our realms of understanding, that it's still an alien entity with enormous power, so to speak, that could be experimenting with us. We could be the petri dish.
Do you
see what I mean?
Okay, I thought you meant your typical UFO.
No.
Greens and grays.
We're
talking the simulation could have been done for us.
Yeah.
All right. Well, I'm not going to argue, but I mean, I have no theories on that. I'm not going to.
Can I add a couple more about the moon being odd?
I'd love you to add a couple more.
Okay. Did you know that you said that the moon is got a molten center. Okay.
It's got lava. It's volcanic. It's got lava. It's got lava. So I don't know what to call it.
The impact craters on the moon are not deep enough. For one, they're all fairly uniform, which seems to imply that the outer casing of the moon, or the crust, is relatively thin, which is really odd, considering if some of the sizes of the craters are enormous, they should have made deeper inroads into the surface, but they haven't. They're fairly shallow, so that would it causes a conundrum. Why is that shallow? What's underneath it to stop it going any further? But there was a really strange effect which shocked scientists on November the 20th, 1969, with Apollo 12. What Apollo 12 did, they jettisoned the lunar module back to the surface, and the moon reverberated like a bell. And it was captured on the seismic equipment. And the thing was, it wasn't just for a short period. It rattled like a bell for an hour.
From just the lunar module?
Yeah.
How heavy was it? It can't have been anything really
Indeed.
for
So,
1/4 the size of the Earth,
yeah.
and it
So,
rattled for 1 hour.
for an hour,
That's
the
weird.
seismic equipment picked
Mm.
up the reverberation for an hour. Now, it wasn't big, it was small, but still there, which was really odd. And they thought, why is it doing that? That would indicate a hollow center rather than a compact
Mm.
center.
Mm.
And during the following mission, a greater payload was jettisoned and the reverberation was measured again. This time, the effect was even greater, and the ringing continued for almost 3 hours. Now, this would imply that there's some hollowness to the
Mm.
moon. But obviously, there's no evidence to prove this or not. It's just this reverberation. And even now, it hasn't been studied. It's almost been shut away as if you don't want to talk about
Does
it.
that not remind you of the opening sequence of that film with Samuel L. Jackson? And who was the star of the film? When they went off, was it called Kong Island? Was there
I
such a?
don't know. I don't think I've seen it. So,
Well, they go to this new island, and the first thing they do, being Americans, is start dropping seismic explosives all over the place.
why?
Well, to study, to
Okay.
study the island, and
Yeah.
and of course, this kind of upsets King Kong. And I just think it's just like us humans to go around and start jettisoning things onto the surface, and to wake up whatever is there and think, what the hell is this, man?
I mean, this coincides. I mean, that reverberation seems to coincide with the impact craters. It's almost like there could be
Yes, what's
some
really
metallic, yeah, that's absorbing it, rattling, and stopping the crust from being
so wouldn't it be
destroyed.
weird if the moon is not actually.
Hot, solid.
Yes, and there really is like an alien presence. Maybe that's the
Well,
moon
that
base for
that is one. That
for
is
studying
one.
us.
Yeah. that is a reason. That is a theory by obviously some conspiracy theorists. So that's why I wondered whether this could be a show that could be partly conspiracy. Because there is a theory to say that the moon is in fact an artificial satellite. As you've stated, where's it come from? It's
Yeah,
actually been placed there because we are being observed by the very beings that are monitoring us over a long period of time. So the moon itself is hollow, made to look like a an asteroid
a
in the
natural
sky.
asteroid, because
Yeah,
the other
when
planets do have moons.
yeah, whereas ours is geostationary, if not
Mm.
geostationary. It's so perfect in terms of exactly what you said, the size, the distance from the sun, just too coincidental. It's too perfect.
Yeah,
And so it could be there for that reason, to observe us, to see what we're doing. So it is hollow, and there are actual beings, far
I wouldn't
more
go that
advanced.
far, but I would say that there's something very not all right in the fact that we can't explain the depth of the impact craters, and almost as if the lava that escapes
Yeah.
is faked for our edification, or to make up, or maybe when it impacts the moon's surface, it, the chemical reaction is to create some sort of lava. So it's not that there's lava underneath the surface and it's coming through. It's that the impact itself is creating the lava. Do you see what I mean?
Hmm. Yeah, possibly. Possibly. It's interesting. Did you hear the theory, again, a conspiracy theory regarding actual Neil Armstrong that wasn't actually spoke about? It was he was reported as saying that when he landed on the moon, he said, "Have you seen?" And then it cut out. Now it cut
I
out
thought he
to
said,
the
"Did you see that?" You know what he said? Did you
yeah.
see
He
that?
did say that, yes, and what he was saying, and they cut it for the population, was that he saw something on the crater line of lights and the spaceships watching the Earth, the humans who'd landed on the moon. And that's why he's never done any interviews since, because he was sworn to secrecy of what he's seen. Now, that's a bit far-fetched. I don't know how we can, because obviously he's no longer here, unfortunately. And but that was one that was reported on that he'd actually said. I'm trying to find what was the actual, what he said.
Yeah, I've actually heard it. I actually said, did you see that?
He did say
that's what I heard. Yeah. So did you see that? He was asking mission control.
Yeah. And the conversation and was been disclosed by this professor who used to work at NASA. And apparently he was having, the images that were coming back were grainy and the quality was poor. Americans heard a little bit, but they didn't hear all of it. They heard obviously the immortal words, one small step for man, one giant leap for mankind. But then there's a crackle and the quality of the broadcast wasn't very clear. And he said, did you see the light on the nearby crater? And mission control asked what for more information, but the transmission went dead. And for 2 minutes, nothing was heard. And an employee of NASA has revealed that the conversation was still going ahead, but not being broadcast. And the conversation was, this Neil Armstrong, what was it? What the hell was it? That's all I want to know. And mission control said, what's there? What's there? And Neil Armstrong then said, these babies are huge, sir. Enormous. Oh God, you wouldn't believe it. I'm telling you, there are other spacecraft out here lined up on the far side of the crater's edge. They're on the moon watching us. Now, this was said that happened during those 2 minutes of radio silence, because as he landed, he turned and he could see it. And they haven't been, obviously the people in the room, there's only a few of them, were having this conversation with Neil Armstrong, and they obviously couldn't reveal that. But it was brought forward by almost a whistleblower who was there at the time, obviously a lot older now, and decided to let out the truth in his words. Now, obviously, that it's just could be nonsense, but there's a lot of.
It would have been nice to have had that corroborated by others on the spaceship at the same time, his companions, who should have heard it because they were all on the same radio frequency.
Well, NASA apparently were warned off.
I don't mean NASA. I'm talking about people on the lunar. Well, because 3 of them landed. There was
Armstrong and all Buzz Aldrin.
3 of them were on the mission.
Yeah, but
there's one person who stayed in orbit.
Yeah, that was.
And 2 of them actually landed on the moon, right?
That was Neil Armstrong and Buzz Aldrin.
Right. So I'm sure the 3 of them were all patched into the same frequency.
Possibly.
Yeah. So why didn't the other 2 say something?
Well, Buzz Aldrin has subsequently said some things since then.
I don't know about that.
Yeah, and also there's been some films which imply it, because I don't know if you saw Transformers: Dark of the Moon.
I don't watch.
No, but anyway, on that they showed clips of Neil Armstrong and Buzz Aldrin landing on the moon. They obviously did it for part of the film, but when the radio silence happened and they showed the reporters, we've lost contact with the Apollo crew for a moment, this was a genuine clip from the American news broadcaster at the time of the landing. But in the film, they show Neil and Buzz heading towards the crater and seeing an alien craft. and NASA talking to them, guys, you've got 2 minutes, just have a quick look. What is that? What is that? And in the film, obviously, they ramped this up. And funnily enough, Buzz Aldrin was in the film himself.
Right.
He made a guest appearance. Now, this is not something which is, just folklore, which is dismissed. They've even gone ahead and put it in a film because they believe that this conversation that Neil Armstrong had with NASA was sort of obscured to us, the public on the planet, but between NASA and themselves, they did have a conversation on things they saw on the lunar surface.
Well, I'm going to leave that one on the back burner for now.
Okay,
I think
it is quite far fetched.
But I will remind the audience. I will remind our audience that you and I, we did ask serious questions about a Chinese probe that landed on the moon. Was it last year?
Yes, that looked and saw a box.
Looked and saw a box, and it promised us that it would tell us what the box was. And it would take about 6 weeks to move this probe towards the box, which you and I both found ridiculous at the time. But how come it takes so long just to move, what was it, 80 meters or something?
No, 200. It was 200 odd meters, something like that.
Yeah, but still, 6 weeks or whatever?
6 weeks, yeah. What was that all about?
And we thought that was ridiculous.
Yeah.
And we never heard about it again.
Well, I did find an article. I found an article and about that, and they were quite glib about it. Oh, yeah, just rocks. Yeah, and they never showed it. They never actually even showed what they thought it was. They just said, oh, it was just rocks.
They said, never came back to us. They just, oh, don't worry about the kind of answer. Yes. Oh, don't worry about it. It just turned out to be, no, was it a rock or like a hole in a cave? It was something you just think, hold on a second, that wouldn't be oblong. So whatever the stupid explanation they gave was, I said at the time, that wouldn't be the shape we saw, because they were almost trying to say it wasn't cuboid.
Yes, but it was.
And it was so definitely cuboid.
Mm.
And they didn't even come up with a good explanation. They said, I think they said it was a rock, didn't they?
Yeah, it was. That's what they said. Oh, it's just a rock. And maybe even show us it. Okay, if you're there close up, show us the rock and show us. Oh, yeah, look, there's a rock. It's a square.
Why did it look like a cube?
Yeah, none of that. They didn't even show the picture. It was just words on a page. Oh, it's just a rock. Don't worry about it. Why did they not show us?
Exactly. And I'm not prepared to accept that.
No, I'm the same. That was really weak as an explanation for something on the base and on the moon. And to me, that was weak.
I hope audience members will actually seek out the original pictures and have a look for themselves and understand why we're saying you can't just say that's a rock, because that's not how nature builds things.
No.
You don't have cubes in nature. It's almost like a Space Odyssey 2000 and the Space Odyssey 2000 kind of thing, with the perfect cube thing. Not perfect, but you know what I mean, that it's artificial to the degree where you need an explanation for this. And the whole thing was silly. Even
it was silly. The answer just didn't make sense to me.
Yeah. So that I think is a question which definitely needs a proper answer, and we're not getting it.
What about all the other theories about the moon? We've sort of touched on where did it come from, and the answer, I suppose, is we don't know.
I absolutely have no idea.
We don't know.
It's there. We look at it all the time, but a lot of the time we don't realize just how peculiar it is.
Yes, it's really very, very peculiar. No, I'm agreeing with you. And some of the things we've touched on today, okay, some of them could be a little bit far-fetched, but so far the explanation from science seems to be a bit far-fetched.
Yeah,
so,
that theory yet again, These wandering astros that do miraculous things and they never show up again, It's pretty amazing.
It does lead, a little bit of incredulous thought in this. But anyway, okay, going back to the moon itself. So we don't know where it come from. I suppose that's roughly our conclusion. What about the other factors then? Do you believe it could be hollow?
No.
Is this the first time you've heard that?
It is. But I don't believe the mathematics would work, because that's why I don't believe in a hollow earth. Because the maths just wouldn't work. It's how it would have a different sort of weight, wouldn't it? And we'd expect different things of it.
But what about this clanging sound?
I don't know. It's pulling the seas, man. All right. That's why we have tides. So that thing is heavy. Okay, otherwise we wouldn't have tides. So how can it be hollow and heavy?
Well, it doesn't have to be. It doesn't have to be completely hollow. Do you know what I mean? You've still got, several hundred miles of
I think it's
crust.
the material it must be made out of that does the clanging thing.
Possibly,
It must be the material and the way that that material
but
acts.
resonates.
Well, it's a bit weird, isn't it? I mean, to
That
be
is
honest,
weird.
because it's just so small of an object compared to the size of the moon. It's like saying that you flick a pea at a fully grown bull elephant and its entire skin judders for hours. It doesn't make sense. That's the thing. The result is far more massive than the cause.
Yeah.
And that is where the maths, just like you think to yourself, how much energy went into the impact to allow this resonance to last for an hour in the first instance and 3 hours for the second? Where did that energy come from? How?
Yeah.
Again, that's just problematic. It's
Yeah.
problematic, man. It's problematic.
Did you know, even though the Soviets hadn't landed a man on the moon, they have successfully put probes on the moon?
Yes, because they've got their own reflectors.
Yes. Did you see one of the photographs? I'll have to share it with you, where this was a successful Soviet moon landing on December the 24th, 1966. And there's a photo of an axle and wheel abandoned on the moon's surface that the photograph depicted. So how the hell? Well, exactly. How the hell? It's 3 wheels on an axle on the moon's surface.
From where?
It's a Soviet.
Soviet axes and things.
No, Soviet photo from 1966. Now remember, no human had set foot on the moon.
Why am I just hearing about this for the first time?
Well, I will send you it. And you can have a read yourself. We can share it on our page as well. And it's interesting. I mean, the evidence is strange because there's a photo here, and you can see that the lander, the Soviet lander, is there's a shadow of the lander just in front of it. So something like an aerial off of it, and you can see this thing with a shadow that is a wheel, 3 wheels attached with an axle through it. And this was crazy. But have a look at this and see what you think. But anyway, we're getting close to the end of the show here, by the way. We've rattled on here about all these bits about the moon, the distance, the size, the convenience element, how it got there. Did you know that there's also stories that in ancient scriptures that talk about the moon coming in its place? So it hasn't been around as long as we think. But how it got there is another story. We still don't know. We still have no idea of how the moon got there and in the orbit that it is. So you did touch on one other thing, the position of the moon, where it takes 27 days to go round. It's 27 hours, is it? On 27 days to go round. No, let me get this right. Apologies. It takes 27 days for the moon to do an orbit of itself, but it takes 27 days for it to go around our planet Earth. So that's why, so even though it's turning on its own axis, but the side facing us is still facing us. That's how it works. So the moon is in fact rotating. It's not stationary. But it takes 27 days to do a rotation. And in that time, it's circled our planet, which is very convenient. And
that's almost like a nod, It's almost
but it's facing our Earth. Now, for a base, that would be perfect because you've got the base constantly facing where you want it to face, which is the Earth. So they can keep an eye on us if it is aliens that have put it there to study us. So we're still debating that. So final conclusion.
I had to think about that a bit. I was trying to imagine in my head So if you've got a point A that is directly above, I don't know, Africa or whatever, okay,
Yep.
on day one, and the next day it'll be pointing slightly away because it has moved on its own axis. The moon has moved on its own axis.
Yeah.
You see, but it's at this point in time, it's no longer over Central Africa. It's now moved a little bit to one way or the other. Doesn't matter which way. All right, and there's
Yeah.
a new B facing the Earth. This is what I mean. So I don't know, I don't understand what you mean by one side will always face, because if it's rotating on its axis, eventually all parts of it would have been seen by the Earth.
No. I'll also send you it's a great little graphic on there, and it shows you how.
Yeah, that's what I need. I'm a video man.
Yeah, you'll see it exactly. The moon does rotate on its own axis at the same rate that it orbits around the Earth. That means we'll always see the same side of the moon from our position on Earth.
Okay, I want to see that.
It's a very good diagram. It's from spaceplace.nasa.gov, and it explains why the moon, we only see one side of it, even though the moon does rotate. It takes 27 days to do a rotation on itself. See, if it was stationary in space, we would see it rotate around. It would take 27 days to do so, but we would see it. But because it's rotating around, but it's going around the Earth, it's rotating 27 days, but the front, that same side is still facing us. You'll see it once you see the graphic.
And my people in Nigeria would say, Ojoro.
What's that mean?
Ojoro. Lies. Deceit. Deception.
Okay, well, let's sum up here because we've got to the end of the show. So where does the moon come from?
Ojoro.
It's a
giant conspiracy, man. 27 days. I didn't even know that. That's amazing. That's even as big as the 400.
It's too convenient, isn't it?
It's a little nice there. It's a little just, It's like you gave the game away, man. What are you doing?
This is how if you had to design a ship that orbits a planet, this is what you would do. This is exactly what you would do.
Well, then, you try to pass it off as a coincidence. Like, come on, man. Okay. That is weird. That's very weird. That's weird. All right. Very weird. Brilliant. So the moon is weird.
Yes, indeed. Unfortunately, we have reached the end of the show for another week.
Mm-hmm. So,